Well, but this is like when both goods or prices are increased symmetrically, right? Then you would expect that not to be the case, right? If the other goods were raising their price too, that would make them less good substitutes. At higher prices, goods are usually less good. If like you symmetrically increase a bunch of goods prices, they're going to typically become less good substitutes for one another, relative to the outside goods, right?
Okay.
Because people, like, I mean, if American cars and German cars both go up in price, right, then it's more likely that you substitute to an Italian car rather than to a German car in response to an additional increase in price. Because German cars have become less good substitutes, you know. Okay, so we saw before, right, in previous classes, that lots of things were summarized by incidence, right? And incidence, in turn, is going to be determined by theta, not by the other details that we're talking about. So in particular, Daiichi, can you go through how the incidence is determined by the conduct parameter?
Incidence of what are we talking about?
So the incidence of attacks, right? So we talked about incidence like of attacks before, right? And in what sense does the conduct parameter, did you read the paper? It's probably not even worth trying to do this if you did read the paper. No, you didn't get a chance to. Okay, so did anyone else read the paper and can do this, or should I just, I'll go through and do it. Okay, so let's ask, how much does producer surplus change when there's an increase in tax, right? Well, an increase in the tax is going to have some effect on the price, right? So that's what we call the pass-through rate, right? Now, remember that the effect that it has on profits, that a tax has on profits, is however much it changes prices times quantities, minus the direct effect of taxes, right? Plus the markup times however much it changes the quantities, right? And how much does it change the quantities? Well, it's dq dp times however much it changes the prices. So this is starting to look a whole lot like the exact same pecuniary, non-pecuniary thing we were doing before, right? So we can replace all these dp dt's by rows, right? And then we just are going to have this m times dq dp, right? But m times dq dp is over negative q times d, right? That's exactly our definition of the conduct parameter. So we can just plug in the conduct parameter here and replace the m by a q, negative q, and we get this formula here, right? So we get negative quantity times 1 minus theta times rho. Okay. Now, how much does consumer surplus change when the tax increases? Well, it's still, the consumers are still behaving competitively. It's still just the quantity times the pass-through rate. So incidence is now the pass-through rate over 1 minus theta times rho. Now, notice that this maps continuously between the two formulas we had from before. So if theta is equal to 0, we get rho over 1 minus rho, which was the competitive formula. If theta is equal to 1, we just get rho, which was the monopolistic formula. Okay. Chrissy, do you want to try doing the same thing for the social incidence calculation? Yeah, you want to give it a try? So remember, social incidence is when we increase the exogenous competition, this like amount that some outside firm is exogenously selling in to compete with the firms in the industry. How much does that affect profits?
So I know you're going to have like a dq not I over dqi term, right?
Well, you don't even need that here now, right? Because we're just doing everything through this conduct parameter, right? So there's just going to be some impact that this exogenous quantity has on how much people in the industry are doing, right? And then we're going to have like, dm, like m times d q time plus, q times dp.
All right, so I'm trying to remember the initial like social incidence formula that we had.
Yeah.
And
It was just, it ended up being just rho in the case of monopoly, right?
it's canceled.
Exactly.
So it's
Exactly.
canceled. What did we start off with?
We started off with noticing that the effect that a change in the exogenous quantity had on the firm's first order condition was the same as the p prime times the effect of a tax. So we went through something like this, right? We had that, okay, so the first order condition from before, right, was that p plus p prime times q minus q tilde, right? The things I was trading off, right, were that I want to set price equal to marginal cost, but then I also have to reduce my price in order to sell more of the inframarginal, of the marginal quantity. I have to reduce my price on all the inframarginal units, right? So now when q tilde increases, there's less of those inframarginal units. Now the first order conditions when we're in oligopoly only put a weight theta on this term here, right? That reduction in reduction in the effective price that I'm getting is now multiplied by theta, because that, rearranging the Lerner index, you would get the exact same weight being put on the anti-competitive things here as in the other equation. So as q tilde increases, the effect is no longer just p prime, it's theta times p prime, right? And so going through exactly the same logic we did before, the effect is theta times rho. That's the effect that a change in q tilde has on q. Okay. Now do you want to try to... Okay, now.
I remember I got confused
Okay.
when the q tilde got thrown in there.
Okay. So the change in producer surplus from a change in q tilde is just like we were doing up here, right? So there's going to be a change in price times quantity, a change in quantity times price, times markup, and there's going to be a direct effect, right? So the direct effect is that we were earning some markup, and now you've just removed some of the quantity from me, right? So that's the markup times -1. The change in quantity is rho times theta, right? And we multiply that by the markup. And then there's a change in quantity times, there's the quantity times the change in price. The change in price is dq, dp, dq times however much the quantity changed, which is theta rho. But now remember that negative q dp over m times dq is equal to 1 over theta, right? So we plug that in here, and we get that the whole effect is negative m times 1 plus 1 minus theta times rho. On the other hand, it's still the case that the amount that dead weight loss changes when we increase the quantity is equal to the markup. And the amount the quantity changes is theta times rho. So dead weight loss falls by m times theta times rho. And so the social incidence is the ratio of how much dead weight loss falls from the exogenous quantity to how much profits fall is theta rho over 1 plus 1 minus theta times rho. OK. And again, this collapses in the case that that theta is equal to 1 to just rho. OK. So both of these formulas are really a mix of the formulas under perfect competition and under monopoly, where sort of the weight on each of them is given by theta. Now, as Carl was pointing out, theta can actually be greater than 1, as it will be with complementary goods, and we'll talk about that later. And we can just integrate these things as we did before to get the global ratio of consumer surplus to producer surplus, or the global ratio of deadweight loss to producer surplus, except that now in the case that theta does depend on prices or quantities, it doesn't under Cournot, and it doesn't under conjectures, but it does under differentiated products Bertrand, then we have to average the product of theta and rho whenever they're multiplied by each other. OK. Eric, can you well, forget about this. Can you we can do some natural comparative statics of these things in theta, right? So this incidence, if we integrate it, gives us the consumer surplus to the producer surplus ratio. So if we increase theta, what is that going to do? That's going to, because the pass-through rate is positive, increasing theta raises the denominator and therefore makes the ratio of consumer surplus to producer surplus lower. That is, as we have more monopoly, the producers are going to capture more of the gains from trade. As we increase theta, you can show, as we increase theta, that's going to increase the top of this and decrease the bottom of this. And therefore, the ratio of deadweight loss to producer surplus rises as we get closer to monopoly. And in fact, it rises more quickly than this does. So actually, even though both producer surplus and deadweight loss are rising as we get towards monopoly, the deadweight loss is going to rise much more rapidly. OK. So by a similar logic to the monopoly case, we can derive the pass-through rate. And it turns out to just be exactly the sort of mixture we would have expected, right? So remember that in the perfectly competitive case, we had that the pass-through was 1 plus the ratio of elasticity of demand to elasticity of supply. Under monopoly, we had that it was 1 over 1 plus the elasticity of demand minus 1 over the elasticity of supply, plus 1 over the elasticity of the marginal surplus. Now all those 1s just become thetas, and we can move continuously between those two, right? But we have one additional potential term, which is that if theta is itself depending on price, that will affect the pass-through rate as well, right? So there are basically two changes from the monopoly formula. We sort of put a weight of theta on the monopoly formula and a weight of 1 minus theta on the competitive formula, right? And I'll give you a graphical demonstration of that in a moment. And then there's one extra term, which is that if the conduct parameter is rising as the price rises, that's going to increase pass-through, right? Because if we're getting sort of more collusive or more market power as the price rises,